Hi, eighth grade. All right, so we started our unit on or section on earthquakes. We're going to finish out this section. Our science test on all of plate tectonics, volcanic earthquakes, all of this stuff is going to be on Thursday the 17th. So we're going to have a busy couple weeks and then we'll be done, and then you'll have a great Christmas and you can just forget that I have a class with you for a little bit and have a little bit of a break. Okay, earthquakes. Earthquakes are what happen when we have these blocks of rock that release energy, they move. A couple of terms we need to talk about. A focus is the place deep within the earth where the earthquake actually occurs. So if we have, like, here's the surface, and you see here you are standing there. Well, let's pretend like your head's attached, but anyway, it's my drawing, sorry. Um, Deep in the earth is where the focus would happen, and that's where the energy actually is released. And then the energy travels outward, kind of like ripples in a pond. So this is going to be your focus down here. Directly above that on the surface is going to be what we call the epicenter. And then the break or the crack where it actually moves is going to be the fault. So I don't know if you can see this picture here behind where my image probably is, but there's that crack that the earth just kind of shifted along, and that's what we call a fault. Elastic deformation is deformation that is elastic as opposed to some of the other types, but essentially what it is, it's like a rubber band. So when a rubber band is elastic, it stretches, but when you let go, it returns to its original shape. And so what happens is that tension will build up and build up and build up. And this is how the faults are right now. And like you would come and maybe build a house on top of this or do roads and whatnot. And when that energy is released, it goes through elastic rebound and it goes back to its original shape. But the problem is we've built on top of the stretched out shape. And so as that energy actually, so we have that stretched out, all that tension, we have that elastic deformation because it's deformed, it's changed shape in a way that it will return to its original shape. That's elastic deformation. The rebound is where it goes back to its original shape and releases energy. And with rubber band, that's where it flies. So this is one part where you're glad you're not in the classroom because I'm shooting rubber bands around the room and trying not to hit anybody. So far, so good. We've just hit the wall, which is what I aim at. I will send you on OneNote a sketch of this elastic rebound of before, during, and after, and how it goes back to its original shape. So you could draw something similar. It doesn't have to be a flag. I just do a flag because it's a rectangle and I can draw it okay-ish. So seismic waves are energy waves that travel through the earth. Seismic wave is just the fancy word for saying earthquake. So when you see seismic, think earthquake. Seismic waves, earthquake waves. And then we collect them using a seismograph, which is this kind of thing here. I do have, let me see if I can pull this off. Hold on here. I have a model of a seismograph that we use in class, and I tried to take a video, so I'm going to play it here and see if you can see this as well. So we have this piece of paper, and essentially the seismograph in the box there. With a seismograph, either you have a piece of paper that will move with the earth and the pen stays still, or the paper stays still and the pen will move. But one of those pieces is stationary and the other piece will move with the earthquake waves. And so you have paper, and when it's still, you see that line. And then when I cause the earthquake, you're going to see the pen wiggle eventually. Maybe. There it goes. And so the larger the squiggle, the more energy it has. And so this is a tool that allows us to actually calculate how much energy is released. So the wider the squiggle, the wave there, the more energy it has. And then we can actually use this to do some math and calculate how far away we are from the earthquake wave or from the epicenter. So more on that when we get closer into our lab. But that's kind of the vocab we've looked at so far. Have a wonderful day, and I will hopefully see you all soon. Let me know if you have any questions.